Hello everyone. In this video we're gonna discuss dilation, and by the end of that video we're gonna be able to define dilation and the center of dilation, recognize the dilation in a coordinate plane, find the scale factor. If you have noticed on the animation on the right is that Steve from Minecraft is being actually either enlarged or reduced. He's either getting bigger or getting smaller according to a value that is being displayed below. So what is this value? How does it affect on the shrinkness, on the shrinking and the stretching of the object itself? So these all come under how do we describe the properties of dilation. Now, before we go on, let's define dilation. Dilation is a transformation that enlarges or reduces a figure in size. This means that the pre-image and the image are similar and are either reduced or enlarged using a scale factor. What is a scale factor? Is the number that each coordinate is multiplied by to get the new image. So a scale factor comes from the ratios and proportions, if you still remember. In order to go on with this lesson, you need to relate it to ratios and proportions. A dilation stretches or shrinks the original figure, and the center of dilation is a fixed point on the plane that all the dilation goes towards it. It's the center of. How can we recognize dilation? How can we say whether it's being enlarged, the image is being enlarged or being reduced? So I'm going to show you three cases, which actually these are the cases that only tell you when is actually the value can tell me when is actually the image is changing in size. If you notice the first one, the dilation factor is given as K, which is 0.5. Okay, in that case, when K is 0.5, this means that I need to look into the pre-image and the image. Have you noticed that the pre-image is bigger than the image? So in that case, since the pre-image is bigger than the image, then I have reducing. Here the image is being reduced, okay, or we say shrinked. The pre-image is being shrinked, and I have here, in that case, it's always between K is between 0 and 1. In the second one, if you have noticed, actually the scale factor is equal to 1. The pre-image and the image are overlapping. They have the same exact size and shape. So here I have no dilation at all. So this is no dilation, and K is equal to 1. So when K is equal to 1, I'm having the same pre-image of the pre-image, which is the image. And the last case we have is the scale factor is 1.3, which is greater than 1. So if you have noticed, between the pre-image and the image there has been enlargement, right? There has been stretching. So the image is stretched, okay, or enlarged. Both are the same when K is greater than 1. These are the only cases that tell you what happens to the pre-image if you're applying it. Now, how do we find the scale factor? This will be our second idea here. Let's go for finding the scale factor. I'm going to give you this problem. Okay? It has A and A prime, B and B prime. All I need to know is to see the change from the pre-image to the image. First, if you have noticed, the size changed from AB to A prime, B prime, it got shrinked, right? So that's, since I'm having the segment has been reduced or is getting smaller, then here I can say very important part is that directly K will be between 0. So definitely I have, okay, this from AB is greater than a prime b prime, so definitely I will say there has been k will be what? Because the pre-image is bigger, so k is between 0 and 1, so it will be a fraction, 0 point something. Okay, how do I find it? I take the x coordinates of a, the a which is 4, 5, it becomes a prime which is 2, 2.5. So I'll take x of a prime over x of a. Okay, it will be 2 over 4, which is 0.5. Okay, y of a prime, to make sure, over y of a, it will be 2.5 over 5, which is 0.5. So in that case, I can say that my scale factor is correct. It is going between 0 and 1, so k is equal to 0.5. That's how I find it. Another way is that taking the lengths of the segment. So I can mark this one here to show you what I mean. Sorry. So I can mark it to show you what I mean. These both are going to be giving me also the image. So if you take, in other words, another method is that if you take f prime over f, it will give you 2.5 over 5, which is 0.5 as well, which is k. So it's either this one or you can use this one. Let's take another. Now we're gonna talk about, now this is a second problem about finding a scale factor. As you have noticed, a prime is my image, ab of coordinates 2, 2 and 5, 1 is my pre-image. How did I know? From the prime. There's no prime on it, so this is my pre-image. And this would be my center of rotation. Okay, in this video, as I said previously, it is going to be the origin is my center of rotation. So when I need to find the scale factor here, I have two methods. Okay, I either find it by using the coordinates, as we have seen in the previous problem I'm going to show you, and or either you get the length of the segments and you divide them by each other. But before we go on, I can sense the problem by looking into the image and the pre-image and compare between them. Since I have in my case here AB and A prime B prime, so AB is actually smaller than A prime B prime, so there has been enlargement in that, so I will conclude that there has been enlargement, and since there has been enlargement, I can conclude that k is greater than 1. So this is one of the factors. I can say k is greater than 1. So when I divide, if I find my value is less than 1, then I'm doing something wrong. So let us take the first method and the second method. Okay, I'm going to take the first method, which we have done before. I'm going to repeat it again just to give you a quick idea about it. So I'm going to say x of b prime over x of b is going to be 15 over 5. You notice that y of b prime over y of b is equal to 3 over 1. Both of them gave me the same value. This is it. This is my scale factor. This is my unit rate, if you still remember. You see? So I found my scale factor. I identified it. It's 3. 3 is greater than 1, so my work is done properly. Now, what if I need to use the length of the segments? So it's very simple. You take a prime b prime and you divide it by ab. Let me show you another method. I'm gonna write it in purple, another method. But why to bother yourself if you already have the coordinates? So it's easier to find it by the coordinates. But In case there's no graphing, they gave you the sides, which actually you need it when you are talking about similar triangles. So I'm gonna say A prime B prime over AB. I just have one segment, so it's fine. It's 9.49 over 3.18. So if I divide them, I'll get 3, which is the same value as I found it when I was dividing the x coordinates and the y coordinates. So my scale factor here is 3. Okay, now if I have C is 5, 3, what would be C prime? Simply, since I found the scale factor which is multiplied, I just need to multiply each by 3. So it will be 15, 9. So when you need to find the scale factor, is that you divide them, but if you need to draw the image, all you have to do is actually, you get the scale factor, or if you use the given scale factor and you multiply it by the coordinates of the pre-image. That's it. So if I have 5, 3, 5, 3, this is 5, 3. Okay, this is my C. It will go for 15, 9. So 15, 9, oops, it's over my drawing. This is C prime. Okay, so this is how it goes between. I have explained how to find the scale factor and how to find the image, the coordinates of the image as well in my second part over here about C. Okay, so you just multiply. Okay, this is a brief idea about how to find the scale factor and how to draw your image. If you have any questions, please do not hesitate to ask. Thank you. Bye.